Chapter 6, Types of Chemical Reactions, Part 2. So the third type of reaction is called a single displacement. So the word single means by itself, and the word displacement means to move. So this is a reaction in which you have one element, so that's your single component, and it's going to replace another element in the compound. So that is the movement that we're going to be seeing. One of the reactants is going to be an element, and the other reactant is going to be a compound. When you are trying to figure out what is being switched, you have to look at the type of element that is by itself. Is it a metal or is it a non-metal? So if it is a metal, then the metal is going to replace the metal in the compound. So that's what like replaces like means. Metals replace metals and non-metals replace non-metals. So in terms of patterning, what you're going to see is in the reactant, you're going to see an element and it's reacting with a compound. And then on your product side, you're going to see the same pattern. You're going to see an element and then you're going to see a compound. However, the element that is in the reactant is going to be different than the element that's in the product, and the compound that's in the reactant is going to be different than the compound that's in the product. What happens is the elements are going to rearrange themselves so that we get brand new products. So the best way to do this, in my opinion, is to label your metals and non-metals within your elements and compounds, and then you can use that to predict what your product will be. So let's do an example together. So the example that I've given you here is bromine plus calcium iodide. So now on the top, I've already written it for you. Bromine is a non-metal, calcium is a metal, iodide is a non-metal. So in this case, we've got our non-metal is our single element. Okay, so our non-metal, I'm just going to circle it here, is our single element. So what that means is that within this compound, it is going to switch places with the non-metal. So that's what like replaces like means. So bromine and iodide are essentially going to be switching places so that calcium is still part of the compound. So if you take a look at your product side, you can see that iodide has now been shifted out of calcium iodide and now is iodine. Because it's no longer a compound, we go back to its original ending, and the calcium is now a compound with the bromine, so we've got calcium bromide. So when you look at your elements here, we've got bromine, calcium, iodine. In the products, we also have the exact same three elements, they've just rearranged themselves. So if you take a look at the chemical formulas here, the chemical equation, we've got the element bromine, compound calcium iodide, and then on the product side, the iodine and the bromine have switched places. So iodine is now by itself, and we get a new compound formed called calcium bromide. So that is called a single displacement. So again, you're looking at a pattern of an element adding to a compound to form an element and a compound. Our final type of reaction is called a double displacement. So single displacement meant one thing is moving. Double displacement means two things are moving. So this is a reaction that occurs when elements in different compounds displace each other and switch places. What pattern you're looking for is in your reactants and your products. The reactant molecules are compounds and the product molecules are also compound. We still have like replaces like, which means metals replace metals and non-metals replace non-metals. So when you're looking at your reaction and you're deciding what type of compound or what type of reaction is occurring, what you have to ask yourself is this an element or is this a compound? So I would recommend that you write E on top of elements and C on top of compounds, and then that will help you decide what type of reaction you are observing. So in this case, in the picture, we've got compounds. So the compound is shown by the fact that there's two different colors on the circle. So compound makes a compound and a compound. Now it's important to note that your products should be different compounds than what you started with. Okay, so let's do an example together. So we've got lead 2 nitrate plus potassium iodide. So this is a compound, this is a compound, and what it's making is lead 2 iodide plus potassium nitrate. So what I would like you to do is on top of the compounds, I would like you to label metal, non-metal. So lead is a metal, so I put an M on top. Nitrate is a polyatomic ion, but it's composed of nonmetals. Potassium is a metal. Iodide is a nonmetal. So what happens here is almost like they are switching partners. So lead is now with nitrate. It's going to form a compound with iodide. Potassium is with iodide. It is now going to form a compound with nitrate. So when you look at your product side, that's going to reflect the switching. So lead is now with iodide, so lead 2 iodide is written down, plus potassium nitrate, which is your final compound. So you still have a compound plus a compound making a compound and a compound, but what has happened is the elements have rearranged themselves so that we're making brand new compounds. So some fun examples of these reactions. So these are not actual reactions, but they're just ways to help you remember the difference. So a synthesis reaction is like two things coming together, sort of like a marriage. A decomposition reaction is like a couple that's breaking up. A single displacement reaction is like, a couple dancing and then someone's trying to cut in. And then a double displacement reaction would be like two couples on a date and they are switching partners. So again, these are not actual reactions, they're just ways for you to help you remember the difference between synthesis, decomposition, single displacement, and double displacement.